let's work this example concerning integration by using integration by part. The aim of this video is which functions to choose when you are dealing with this kind of problems. uv prime is uv minus u prime v. Which one to choose as u and which one to choose as v or v prime, or vice versa? What can we do? We're gonna work this problem here and see what we can do. Okay, in our case, if we choose v prime as x squared, okay, if we choose v prime as x squared, we see that here on the right side here, we will have to get v, which is going to be x cubed. The cosine, when we differentiate the cosine, it's going to keep bouncing back, sine, cosine, or minus sine, minus cosine. It's not going to go. And the powers, if we integrate again one more time, the powers of x, they're going to keep increasing. Okay? In our case here, the good thing is to choose the function that we differentiate as the one that will go faster or that will disappear from our integration. And x squared, it's better to differentiate this one because we do it twice and it will go. Okay? In our case here, the best option is to choose the function that we integrate as the one that will disappear from the integral, the x squared in our case. So if we choose u as x squared, then u prime is going to be 2x. And if we choose v prime as the cosine, then v is going to be the sine. And therefore, if we evaluate here, we see that we're going to have uv, that means x squared sine x, minus u prime, which is 2x. I'll take 2 outside. It's going to be 2x times v, and v is sine x. Okay? I get into a similar looking problem, but with one less degree. Now, I'm going to do the same thing here for this integral. If I have x sine x dx, when I use integration by part like this, uv prime uv minus u prime v, my aim is to choose the function that will help me get rid of this power here. Because if I get into sine or cosine, I know how to integrate. But with these powers, the task is difficult. So my option here is to choose u as x and v prime as sine x. And therefore, I have u prime is 1 and v is minus cosine x. Therefore, applying here, so here I should get a constant. Okay, don't forget about the constant. Here, I'm going to get uv, that means minus x, cosine x, minus u prime v. U prime is 1 and v is minus cosine. And with the minus, I'm going to have a plus here. Cosine x, okay, dx. And once I evaluate or I integrate, I get minus x cosine x and sine x plus c. Okay, so I see here, if I had done it the other way around, if I have chosen v prime as x squared, okay, so let's do one quick example. If I had chosen u as the cosine and v prime as x squared, so I differentiate, I'm gonna get minus sine x, and v is gonna be x cubed over 3, and therefore I have this one here. It's gonna get me minus sine x over 3 times x cubed minus, with this minus here, it's going to be plus sine x times x cubed dx. And the powers, they're gonna keep getting bigger and bigger. And therefore, if I choose this option here, I'm not gonna solve the problem. So I choose the one that will help me reduce the powers of x. Okay? So that's the key here. When dealing with this kind of integrations, we choose to integrate. There is a trick, there is a technique that we can use. We can choose the powers. Let's choose as differentiate, and the cosine as integrate. So here, the x squared, I'm gonna differentiate one time, 2x to 0, and I do integrate the cosine, and I cross multiply, and I add plus minus, and I keep crossing, I keep multiplying. We're gonna come back to this one here and give more detail about this technique. But here it's the choice. We will explain why we have to get rid of the powers. So the choice is very important. Which one to choose? You choose u as x squared and v prime is the cosine, or you choose u as the cosine and v prime is x squared. So this is a better option, okay? Because we want to get rid of the powers. That's the key to doing integration by part. Thank you. We might have made some mistakes, but the aim is just to explain the idea and see which one works. Okay? Please like, share, comment, and if you see any errors, please let us know. Thank you.